Welcome back. This is Mr. Hassan's Maths channel, and we're now answering question number 8, part B from the June 2024 Pure Mathematics P4 paper from the Edexcel International A-Level exam. Part A was about the expansion of this binomial, and we had to now in part B use the answer, but part B is about a different topic than binomial expansion, so that's why I have saved this in a separate video. And this is about the topic of proof by contradiction, which is one of those topics that were introduced with the new P1, 2, 3, 4 syllabus. And this is the type of proof that is in P4, proof by contradiction. So it says use proof by contradiction to prove that the curve with the equation y equals 8 plus 8x minus 15x squared does not intersect the curve with the equation y equals a minus 8x plus x squared over 2 plus bx cubed, where a and b are the constants found in part A. And those were the constants found in part A. Okay, so basically what we have to do is the following. And very important, by the way, is this point here, that that they do not intersect in this interval between x is greater than 0 and x is less than 8 over 3. Right, so now let's make a start with this. So when you do proof by contradiction, you have to first basically write down a statement which contradicts the original statement. Okay, so we are going to assume the opposite of what has been stated. So we're going to assume that the curve with equation, I'm going to try and be on my best handwriting now. The curve with equation y equals 8 plus 8x minus 15 over 2x squared does intersect the curve with equation y equals, now a is 16 minus 8x plus x squared over 2, which is like a half x squared, plus 1 over 24 x cubed. Okay, does intersect the curve with the equation. You can say at least once, so just does intersect it. Okay, now in the interval, very important, in the interval x is between 0 and 8, x is between 0 and 8 over 3. Okay, so we have now made a statement which contradicts the statement that we have to prove. Okay, so we have contradicted the statement that we have to prove. And with proof by contradiction, it kind of like you start off by negating, okay, what you have to prove by assuming the opposite of it, assuming that it's not true, and then you have to show that that leads to some type of, logical or algebraic kind of, contradiction, which causes, us to realize that, what we assumed can't be true. So the opposite must be true, that there must be, in this case, an intersection. It's kind of like a very simple example. If somebody comes to you and says that you robbed the bank, say, okay, let's assume I did rob the bank. So you're trying to prove you're trying to prove that you did not rob the bank. That's what you're trying to prove. Okay, so what you're doing is saying, okay, I'm trying to prove that I did not rob the bank. So what you say is, let's assume that I did rob the bank. Okay, let's assume that I robbed the bank. Okay, now that would lead to certain conclusions, which there's a lot of holes in this example, but just to give you a general idea. So if I say, okay, I'm trying to prove I did not rob the bank, so I'm going to say, let's assume I did rob the bank. If I robbed the bank, I would have lots of money, I'd be rich. Well, I don't have lots of money, I'm not rich, so there's a contradiction there. Okay, there's a contradiction there. So therefore, that means, the assumption that I made is not true. so I did not rob the bank. That's like a very simplified type of example. So here we're saying, let's assume that we're trying to prove that these two curves do not intersect in this interval. Okay, they do not intersect. So first of all, we make the assumption that they do intersect. And we try to find that intersection. And we will be able to show that that leads to some sort of logical or algebraic problem where, you know, it shows that they can't intersect. Okay, so if I'm now if I want to solve these two equations simultaneously, okay, I will find the points of intersection. Okay, so to try to find the points of intersection, I have to solve these equations simultaneously. So I can take this y and replace it with what y is equal to. So I can take this and replace this y with it. So I have 16 minus 8x, 16 minus 8x plus a half x squared plus 1 over 24 x cubed is equal to 8 plus 8x minus 15 over 2 x squared. So if I try to solve this equation, I should find that it has no solutions. Then that would, you know, prove our assumption is wrong, and then the original assumption or the original statement therefore would be true. So what we're trying to do now is to try to show the steps to solve this equation. So I'm going to make everything on one side, make it equal 0. So on this side, I have 1 over 24 x cubed. I'll write it in descending order. There's no other x cubed terms. And here I've got a half x squared. And when I add this, I'll have a half x squared. I'll just write the steps down. Plus 15 over 2x squared. I've just added this to both sides. And then I've got minus 8x. And I have minus another 8x. And then I have 16 minus 8 equals 0. So this gives me 1 over 24 x cubed. I got 16 over 2, so that's plus 8 x squared minus 16x plus 8 is equal to 0. So this basically equation here, if I can show that this has no solutions in the interval between x being greater than 0 and less than 8 over 3, then I can show that there's no solution, which means our assumption is false, okay, which means they do not intersect. All right, so how do I show this? Now, this is what stumped many students in this question, in this particular question. They got this far, they know exactly how to do proof by contradiction. They know they have to prove this has no solutions. And many students came to me after the exam saying, sir, how could we prove that a cubic has no solution? We can't use the discriminant for like a quadratic where you could use b squared minus 4ac is, less than 0 to show it has no. How do you do it for cubic? We don't have a cubic formula, or we don't know the cubic formula, whatever. And did we have to know the cubic formula and all these kind of things? No, you don't have to know the cubic formula. However, this is a bit of a toughie, right? Now, in general, a question like this, okay, this is like one of those extension type of questions. Okay. Now, there's a couple of ways of doing this question. Some students actually try to do it in this way. So we have a cubic here. So the easiest way to do it, I'll explain at the end, because that's not the way that most people would think of. Most people would think of what they have in their understanding, and they'll understand that this is a cubic curve, and a cubic curve with a positive x cubed. So it's going to have a maximum and then a minimum, and then it's going to go like this, possibly, or it could have a point of inflection and go like this, whatever. So we have to work out first the stationary points of this. If we can find the coordinates of the stationary points, then we can have an idea of how this looks. We're concerned about this graph between a very specific range, between x equals 0 and x equals 8 over 3. And we know that this graph definitely passes through plus 8. The graph of this y equals 1 over 24 x cubed plus 8x squared minus 16x plus 8. This is the equation that represents the solution, okay, of the intersection of those two graphs. So we know it goes through 8, okay? And we know it's got this type of shape if it has two turning points. So let's see. First of all, let's find dy dx. That will tell us about the gradient of the graph. So that's going to be 3 times 1 over 24, which is 1 over 8. x cubed plus 16x minus 16. So we want to find where 1 over, so x squared, not cubed. Okay, x squared. So we want to find where 1 over 8 x squared plus 16x minus 16 is equal to 0. When dy dx equals 0, we have the stationary points. Okay, so to solve this, we could use a quadratic formula. X equals minus b, so it's minus 16 plus or minus the square root of b squared, which is 16 squared, minus 4 times 1 over 8 times minus 16 over 2 times 1 over 8. We don't have to make them into integers, that's fine. Making the integers will make the numbers quite big. So it's perfectly fine to do it like this, it will work. And we can find out the value or values of x if they are. It looks like there are going to be some solutions, 2 solutions, because this will be minus and minus positive. So it looks like that will definitely give us an answer. So let's put this in the calculator. So we have minus 16 plus the square root of 16 squared minus 4 times 1 over 8 times negative 16 divided by a quarter, basically 1 over 4. All right, that gives us 0.9923, which is a positive value somewhere over here. So there's going to be a turning point somewhere over here. We can find the y value of this by putting this back into the original equation. So the y value of this will be, let's call this x1, when we put this value back in here. So let's just do this directly. So when you're going to have this value, which is now our answer, so I'll store this as a, okay, and I will put it into this equation. So I have 1 over 24. I have to use the original equation to find what y value is, times the answer cubed, okay, plus 8 times the answer squared minus 16 times the answer plus 8. And that gives us 0.0411. 0.0411. So it's going to be somewhere really close to the y-axis. It's going to turn. It's going to have something like this. Okay, and it's going to go back up again. So we can kind of see that between 0 and 8 over 3, that's going to be a minimum. Okay, let's look at the other minimum point. The other minimum point would be, if we change this to a minus, or the other turning point, sorry, not the other minimum, change this to a minus. This is at negative 128. So somewhere over here, that's where it's going to turn. Okay, that's where it's going to have its maximum. So obviously it's going to have a maximum somewhere up here and come down here. So this would be minus 128 somewhere. So it's going to go something like this, and then like that, and go back up again. So we can see that in this region, just by looking at this graph and understanding that, it's going to, at 0, when x is 0, y is 8. And when x is 8 over 3, it's obviously going to be up here somewhere, because that's the lowest it goes in this region. All right. So we can see that between 0 and 8 over 3, okay, we could put this value, if you want, 8 over 3 in here and see what we get. Of course, it's going to give us a positive value. So we can see from this little sketch of what the graph looks like that it's going to, in this region, always be greater than 0. Okay, so we can see that the graph of the solution equation will never touch the x-axis in the interval of x between 0 and 3 over 8. Therefore, there is no solution there is no solution, okay, in this interval, which therefore the curves do not intersect in that region. Curves do not intersect in this interval. Okay. All right. So our original assumption is false. Therefore, the opposite is true. Opposite is true. Okay, they do not intersect between x equals 0 and 8/3. Okay, something like that. Please do excuse my handwriting. All right, so that's a very long-winded way of showing it. Okay, and that was acceptable to show that the turning point here, there's two turning points. There's a maximum and there's a minimum. Okay, the minimum occurs somewhere between 0 and 8/3. The maximum is a negative value, and the minimum is over here is such that you never ever, it turns just before it reaches the x-axis. So it's always going, there's not going to be any root. This will not have a value of 0. Therefore, there's no root in this region here. Every cubic equation has a root, because a cubic equation goes from negative infinity to positive infinity. So somewhere along the line, it's going to hit the x-axis. Okay, as long as if its domain is unrestricted. But here we have a restricted domain between 0 and 8/3, and in that region, the curve never hits the x-axis, which means there's no roots. And that's what we have to prove. Now, that's a bit of a long-winded proof, to be honest. Okay, and there is another way, which is what there was probably intended in the mark scheme for you to answer in that way. Okay, although they have mentioned some of these other methods here. Okay, now, so I'm going to just get rid of this and hopefully write the final answer in a neater way. But this is what was actually intended. What I wrote there was fine, you'd get the marks for it. I could have left it and did another page, but I just crossed it all out, no problem. Now, the other method for us is to show that this expression will never ever be equal to 0. Now, how do we do that? With quadratics, we complete the square. So we can't really have completing the square with something like this. However, we can look at the x squared and the x term. So you have 8x squared minus 16x, and you're going to have plus 8, and then you have 1/24 x cubed. Okay, that's right. Okay, and you have plus 1/24 x cubed. Now, if I complete the square for this part here, remember our x value we're looking for is between 0 and 8/3. Between 0 and 8/3, this is always going to be positive. Okay, it's going to be greater than 0 because that's greater than 0. And you're going to have a positive number cubed times 1/, this will be positive. In this region, this will be positive. How can I show what happens to this part of it? So this is going to be positive for sure in this region, in this interval. Here we have a quadratic part to the graph, a quadratic part. If we complete the square for this, that may help us to, solve this issue. So I'm going to take out 8 as common, which will leave me with x squared minus 2x plus 1. And I have plus 1/24 x cubed. So here we have a perfect square, basically. X squared minus 2x plus 1 is the same as x minus 1 all squared. Okay, if you complete the square for this, you have x minus 1 squared, and then you're going to have minus, you're going to have minus 1. Okay, and then you multiply by the 8. Okay, and so you have x minus 1 all squared, and then you have minus 1. Okay, so that will give us this. Okay, and x minus 1 all squared. So yeah, you have x minus 1 all squared minus 1, and then you have plus 1. Okay, so this part is the same as this. This part is the same as that when you complete the square. X squared minus 2x plus 1. You have x minus 1 squared minus 1. That's that part over there. And then you have plus 1 at the end. Plus 1 over 24 x cubed. We could just write this in one go as 8 times x minus 1 squared, because this is x minus 1 all squared. Right, so we don't need to actually complete the square there. We could just write it like this. So you have y equals 8 times x minus 1 squared plus 1 over 24 x cubed. Now I know that 8 times x minus 1 squared is always greater than, 0. Okay, always greater than 0 in the interval x is greater than x, 0, x is greater than 0 and less than 8 over 3. Because whatever goes in here is going to be squared. It's going to be positive always. Okay, and I also know that 1 over 24x cubed is greater than 0 when x is between 0 and 8 over 3. Because you've got a positive number that you're putting in here and cubing times a positive number. So they're going to be positive. So therefore we can say 8 times x minus 1 squared plus 1 over 24x cubed is greater than 0. Okay, for the interval 0 is x is between 0 and 8 over 3, which means therefore this never equals 0. Okay, which means that a half x squared cubed, a quarter x, 1 over 24x cubed plus 8x squared minus 16x plus 8 equals 0 has no solutions in this interval. Okay, so that contradicts our original statement. Okay, I didn't get rid of this part, sorry. That's from the original. So I could have left that actually, but it was a bit messy. So this contradicts our assumption, okay, that there are solutions in this interval. Okay, so therefore the curves do not intersect. Do not intersect for the interval of x between 0 and 8 over 3. Okay, so that should be enough for you to get the marks. A bit long-winded, but that's what they were kind of intending, an algebra. They were intending for you to do this algebraic type of, analysis of this to show that in this interval that this can never become negative. It's always going to be greater than 0. It can never equal 0, which means that it's going to there's not going to be any solutions in that interval, which means that they don't intersect in that interval. Okay, so that concludes part B. Other questions dealing with proof by contradiction can be found in the playlist that will appear at the bottom right of the screen at the end of this video. Other questions from this particular paper, including part A of this question 8, you can find it in the playlist that will appear on the top right of the screen. You can subscribe to the channel by clicking on this link, and the video here at the top will show you how to use my channel to find those things that you might be looking for. Thank you for watching and see you soon.